Okay, welcome to 6.4, solving trigonomic equations using identities. So these equations we're going to solve look very similar to what we've already done in other units, except for this time we have an identity we might have to substitute in to make it solvable. So in our case, we're looking over the domain of 0 to 2 pi, so we're dealing with radians, and we have this equation sine 2x minus cos x equals 0. So we have a double angle identity here. We can actually substitute in then 2 sine x cosine x, and we still have the minus cosine x equals to 0. Now, we have a cos x in both terms, so that means I'm actually able to factor out that cosine x out of both terms, and I get 2 sine x minus 1. It's still all equal to 0. So now we have this situation where if either term or factor is 0, then it doesn't matter what the other factor is. So we have two cases. We have where cos x is equal to 0, and that happens two places, and we're looking at the unit circle, so pi over 2 and 3 pi over 2. That's case 1. For case 2, we have 2 sine x minus 1 equals 0. So we're going to add 1 to both sides and divide by 2. So then looking at the unit circle, we'll see that there's two spots where this occurs at pi over 6 and 5 pi over 6. Now we should double check that all of those answers actually fall within our domain. They do, making sure our domain hasn't been extended to another rotation or possibly a negative rotation. And it isn't. It's just a normal domain. Okay, moving on. So our next equation, same situation, same domain, and it's asking us to solve this. Now it might be tempting, because we know we need to make this equal to 0, because we've got x and a cosine, and sine x squared in the last question was already equal to 0. Subtracting this 3 off of both sides would actually get rid of the hint the question's trying to give you. So I'm just going to erase this here. We have an identity already set up here, 1 minus sine x squared. What kind of alerts me right away to this is we have the squared part and we have a 1 by it. So if you go look on your sheet, you'll see that we have sine x squared plus cos x squared is equal to 1. So I could actually rearrange that to be 1 minus sine x squared by subtracting sine x squared off both sides. So now I can substitute that value into my equation. So we still have 2 cosine x. But now this whole part, 1 minus sine x squared, is about to become cosine x squared. Now this is still all equal to 3. We should now make it equal to 0. And I'm going to rearrange it so our highest degree is first. So we have cosine x squared plus 2 cosine x, and then minus 3 equals to 0. Well, this is in the form of a trinomial. It very much looks like PSA factoring. So if you're having a hard time recognizing it, you could substitute values in for cosine x, and it become a squared plus 2a minus 3 equals 0. And then you could solve it from there to be a plus 3 and a minus 3. At this point, maybe some of you don't need to do that, and you might be able to recognize right from here that this actually becomes cosine x plus 3, and then cosine x minus 1, all equals to 0. And you can see that the two are actually identical. You just have to substitute back in for the a value. All right, so now we're back to having two cases. So the first case is when cosine x plus 3 is equal to 0. So we're going to subtract 3 off of both sides. And we run into a bit of an issue. This is actually outside of cosine's domain. So therefore, there is no solution to this. So make that very explicit, no solution. Again, if you've forgotten, cosine is only from -1 to 1 are our only values that we can find. Okay, so let's move on to our other case then. So where cos x minus 1 equals 0. So I'm going to add 1 to both sides. And looking on our unit circle, we can see there's a couple places, or only really one place potentially, where cosine is equal to 1. However, so that's at 0. Now this is where you got to be really careful. We go look at our domain, and we actually do have this equal sign here for the 2 pi. So that same coterminal arm is actually going to be part of our solution. So at 2 pi. And that's going to be our only two solutions for this then. Okay, moving on to our last question. So same domain, still dealing in radians, just a new equation. For this one, we're looking, I see I have a double angle sitting here. It's a little bit tougher with cosine to just be like, oh, I know it's got to be this one. We have to think a little bit ahead. I've got a +1 here. To me, that's like a hint. I need to get rid of that +1 somehow, would be nice. I go and look through my identities, and yep, sure enough, there is one that has a -1 in it. So cosine x squared, -1 plus 1 minus cosine x equals 0. Well, this turns out really nice very quickly. These -1 plus 1 is 0. So then we have 2 cosine x squared minus cosine x equals to 0. And now hopefully we notice at this point that cosine is in both terms. So again, we need to factor. So I'm going to factor a cosine x out of both terms. And so we get 2 cosine x minus 1. And so now we're back in that same position as our other two questions. We just need to figure out when each of these factors is equal to 0. So our first case is when cos x is equal to 0. Well, that occurs when x is equal to pi over 2 and 3 pi over 2. And those are again off the unit circle. Our second case is for 2 cosine x minus 1 equals 0. So we're going to add 1 to each side and divide by 2. So we need to find out then, well, where on the unit circle is x equal to 1/2, or cosine x equal to 1/2. So we get pi over 3 and 5 pi over 3. So now we have 4 answers in total, and we are complete.